For question 1, there are various methods we can use. First method is to find 17% of 272, probably by finding 1% first and then multiplying by 17. My preferred method would be the decimal multiply method. So if we start with 100% and we subtract 17%, that obviously gives us 83% remaining. And as a decimal multiplier, that's 0.83, just from dividing by 100. The whole point of a decimal multiplier is that I can just multiply by the number I'm starting with. So 272 multiplied by 0.83, which is 225.76. Question 2. So the layout here is crucial, really. I'm going to start with compound. And my compound formula is original amount times by the decimal multiplier. Better figure that out on the side here. So if I start off with 100%, and add 5%, then I have 105%. As a decimal multiplier, that's 1.05. So it's original amount times by the decimal multiplier to the power of time. And that gives me a decimal with a lot of decimal places. Because it's money, I'm going to round it to 2 decimal places. I'm going to put my units in as well. So that's £325.78. For simple interest, if you remember, the method is to find the interest for the first year, just multiply it by the number of years and then add to the original. So the original is 200. 5% of 200 is obviously £10. So that'd be the first year's interest. So £10, and there are 10 years. So it's £10 for each of the 10 years. Pretty obviously that's going to be in total £300. Then I just need to make sure that I've actually read the question. The question is, how much more would there be in the account? So my final task is to do a subtraction. And again, make sure I put units in my final answer. Question 3 is a classic reverse percentages question. We've been given the new cost when a percentage change has already happened, and we've got to try and recover the original cost. Now, if I was applying a 15% off sale, I would start with 100%, I would take away 15%, that would leave me with 85%, and as a decimal multiplier, that would give me 0.85. Now in this case, I'm not applying a 15% reduction, I'm undoing it. So instead of multiplying by 0.85, I'm going to divide by 0.85. So that is 97.75 divided by our decimal multiplier for 15% reduction. Which gives us, again, I'm going to put this with units, £115. Question 4, again, is a comparison question. So the layout, again, is going to be key to getting all the marks here. So our percentage increase formula is going to be the actual increase divided by the original amount, very important, and then multiply that by 100 to change it into a percentage. So first of all, 30 to 35. We're going to have the actual increase, which is 5, divided by the original, which is 30, and we're going to multiply that by 100, which is 16.6 recurring percent. From 20 to 24, the change is 4, the original value was 20, multiply that by 100, and this time I get an answer of 20%. Now, really important that we answer the actual question, which is the greater percentage increase. So even though it's perfectly flipping obvious at this stage, I still need to say explicitly that from 20 to 24 is the greater percentage increase. On to question 5. Our guiding principle with these equations with fractions is if I want to get rid of a denominator in an equation, I multiply everything by that denominator. So my next line here is going to be what happens when I multiply both sides by x. And the whole point of that is it gets rid of the denominator on the left-hand side, and I end up with 6x on this side. Clearly I'm going to divide both sides by 6 now, to get my answer that a half is equal to x. For part B, exact same principle. I'm just going to have to be careful when I'm multiplying by x plus 1. And just to take that extra little bit of care, I'm actually just going to leave the brackets in as my first stage of working. Multiply the brackets out carefully. I'm going to subtract x from both sides. And I'm going to subtract 2 from both sides. Always worth going back to the original equation and checking that what you've got makes sense. If I substitute back into the original equation, I get 8 divided by 4 equals 2. Makes sense. Question 6, we've got a combination of algebra and geometry. Although it's not strictly necessary, I'm actually going to write on this shape the missing side lengths. So the difference between the top and the bottom is a plus 4. And the difference between the right hand and the left hand is 2. It's going to be helpful when we come to finding the area of this shape. So first of all, I need to deal with the perimeter. In order to do that, I suppose I need to find A. So the whole perimeter is just the 6 sides added together. It's equal to 32, and I'm just going to write it out long ways. There are some shortcuts we could take here, but let's just do the whole thing. When I simplify that out, with a bit of luck, I get 6a plus 20. So solve this equation now, subtract 20 from both sides, and divide both sides by 6. So I've discovered that a is equal to 2. Now I need to look at the area of the shape. I'm actually just going to write on my diagram again, I think. Perhaps I'll draw a separate little diagram on my notes. Notice that it's not even nearly to scale. Neither my sketch nor the actual original diagram are even nearly to scale. So we've got 4 down here, we've got 6 here, and we've got 10 up the top. So the easiest way to calculate the area here is to treat it as a compound shape, which is a larger rectangle with a smaller one taken out of it. So the larger rectangle is going to be 10 by 6, and the area that's been subtracted is a 6 by 2 rectangle. And because our units were centimetres, I'd better pop that on the end. Question 7, although it gives you information about the interior angle, it's actually easier to work with the exterior. So the exterior angle is 180, take away the interior, so 20 degrees in this case. And we know that the exterior angles of a regular polygon are just 360 divided by the number of sides. Quick bit of rearrangement. Tells us that we've got 18 sides on this shape. For question 8, we're going to use again the fact that interior and exterior angles add up to 180 degrees to find x. So 4x plus x plus 30 is going to give us 180. Tidy this up a little bit. And x is going to be 30 degrees. Now to find the sum of its interior angles, we need to figure out how many sides there are. So if the exterior angle is x plus 30, and the exterior angle is 60, we know from the previous question the number of sides, n is going to be 360 divided by this exterior angle. So there are 6 sides. And from this stage we can go down various routes, but let's say we know that the interior angle is 4x, we know that from the question. So the interior is going to be 4 lots of 30, which is 120 degrees, and there are 6 sides, so 6 interior angles. So the interior angle sum is going to equal 120 times by 6, which is 720 degrees. Question 9. The semicircles have radius r. Just be a little bit careful on this one. It does mean that the triangle side lengths are obviously going to be our 2r. We're also going to take a little bit of a shortcut here by saying that since we have 2 semicircles and they have the same radius, we can slot them together to make a single circle. So I'm going to bunch these 2 semicircles together to make a circle. And I'm going to say that the area of the whole thing is therefore equal to the circle area, which is pi times by r squared, plus the area of the triangle that has side length of 2r, so it's going to be a half times by base times by perpendicular height. So let's tidy this up a bit again. So pi r squared plus a half times by 4r squared, or pi r squared plus 2r squared. The question does ask us to factorise this expression as far as possible, so in other words looking for factors that are in common between our 2 terms. The only thing I can see is r squared. So I write that in front. What do I multiply r squared by? That gives me pi r squared. What do I multiply r squared by? That gives me 2r squared. And we're done. I probably ought to... there are no units in the question, so we don't need to worry. Question 10. Finally, very easy to finish one. The 100th term of a sequence with nth term n squared plus n minus 1. The trick here is to find the 100th term. We would substitute n equals 100 into the expression. So it's going to be 100 squared plus 100, take away 1. It's going to be 10,000 plus 100, take away 1. So therefore we're talking about 10,099. I hope this is helpful. If I've made any obvious errors, do ping an email to me. And if you've got any questions over the weekend regarding the test or anything you're trying, any practice material, do ping me an email and ask.